I have an apple, a potato, and a liquid. A liquid number 1. If I put the potato into this liquid, it sinks. If I put the apple into this liquid, it floats. And if I use a piece of potato and a piece of apple, the result is the same. So, the potato always sinks, whole or in pieces, and the apple always floats, whole or in pieces, in this liquid water. Let's see what is different between two pieces of potato and a piece of apple. I use two pieces with the same value. The apple floated and the potato sank. So the potato always sinks and the apple always floated. Let's weigh them. The potato weighs more. The concept that involves mass and volume of an object is density. I have a second liquid and a third liquid and a piece of apple and a piece of potato. In liquid number 2, I'm going to put the apple. And the liquid number 3, I am going to put the potato. The potato is floating and the apple sank. The potato floats in the third liquid and the apple sinks in the second liquid. Because the potato is less dense than more liquid number 3 and the apple is denser than the liquid number 2. The liquid number 2 is alcohol and the liquid number 3 is salt water. The density of the liquids are water 1.000, the alcohol 0.791 and the salt water 1.700. So this experiment shows us that not only the density of the object is important, but also the density of the liquid. Thank you for your attention.
Hi, here I have two equal solutions with two balls of olive oil. I would like to make this ball to sink. So with these values of density, I should put alcohol because it's less dense than the olive oil and the denser goes down. So I'm going to put alcohol. And the ball goes down. In this solution, I would like to make this ball to go up, so I should put water. I don't have salt water, so I'm going to put water. And the ball goes up. So it happens because if we change the density of the liquid, we can control the behavior of the object. In the Alexander's experiment, the denser always go down, and the less dense always float. So when I put alcohol, I'm decreasing the density of the liquid, and the ball that is denser than the liquid goes down. When I put water, I'm increasing the density of the liquid, and the liquid becomes denser than the ball of olive oil, and this ball goes up. In this experiment, let's see. I can control the object because I'm magic. Indeed, it is not magic. It goes down because I press the plastic bottle and it goes down. If I drop, it goes up. It happens because there is air inside the test tube, and when I press the plastic bottle, the water enters to the test tube and increase the mass of the test tube and increase its density. And when I increase the density of the test tube, it becomes denser than the water and sink. So we can control the behavior of the object if we change the density of the liquid, like in this experiment, or if we change the density of the object.
Hi, to start, I want to explain why apples float always in water. Like you saw in Alexander's experiment, even that I push it, the apple always comes up. Well, there are two forces in action here. That is, the weight of the apple and the force that water applies on the apple, that is, the buoyancy. For the apple not to sink, buoyancy at least equal than the weight of the apple. Now I have a potato. You know that the potato thinks, but even that there are buoyancy. In this experiment, I start by verifying the weight of potato. So, this is 1.3 Newton. I'm going to put the potato in water and I weigh it again. Well, in water the weight is 0.05 Newton. The value of buoyancy is the difference between these two values. So the buoyancy is 1.25 Newton. There are buoyancy in some case that the object was put in water. Here I have a scale where the sides are equilibrated. I'm going to put this side in water. Now the scales are disequilibrated. I have to add some water in this object. Now the sides are again equilibrated. I have to add here the value of the weight of the water that was dislocated. This is the buoyancy. I have already finished. Thank you.
Hi. We want to switch two different liquids with different densities from their respective cups. We want to put the olive oil in this cup to this other cup, and the water in this cup to this first cup. We don't have a third cup. We only have this cup, and a playing card. Let's see how we can do this. So what's happening? The oil is flowing up and the water is flowing down. What we had here was the fact that the difference of densities made the water flow down and the oil flow up. When we put those two liquids in contact, the one that is denser has to be under, and the one that is less dense has to be up. Now we should be able to take the olive oil out, and here we have it. We changed the olive oil that was in this cup to this cup, and the water that was in this cup to this first cup. We hear the environmentalists saying that the polar melting is responsible for the increasing of the level of the seas. We're going to prove if that is right. We have here a test tube filled with water. This water is entirely solidified. It's ice. You're going to mark the level of it. And now we are going to melt it. So here we melted the ice, and what can we see? The level of the water decreased. We have here a lower level than we had before. There was a decrease of the level. So let's see another experiment. We have water, and we're going to addict an ice cube. So let's mark the level of the water. So we've melted the water or the ice cube, and what we can see is that there was a maintenance of the level of the water. So with these two experiments, where there was decrease and maintenance of the water level, how can it be true that the environmentalists say that the polar melting increased the level of the seas? Actually, the polar ice is almost all outside of the water. It's not what we have here. We mark the level of the water when the ice is already inside it. In the case of the ice in all the world, we have ice that is addicted to the water. And when water is addicted to the water, we have a volume increase. The volume is higher.